Will return, but I'm not that good. Okay, math. Whew. Okay, any questions besides Miss Compton? Do you actually know my name? Because clearly that needs to be asked. Okay, well, I hope you enjoyed your break. So today, we're going to do math, because why would we come to school if we're not going to do math in math class? I could stay home for one. Not new me. Today we're going to start with new math workshops. I knew there were more questions. Math workshops, eventually there's a test. What category does that test go in? Goes in the 60. Goes in the 60. Your favorite word comes up first. Factor. Okay, so let's recap what we've been doing in math class lately. We've had math workshops for forever, and they seem to always be factoring. Lo and behold, you come back after Christmas break, and we're still factoring. Now, there's a tiny typo. That should be an A, because we're trying to venture out and not only use X's, because, my gosh, there are 26 letters in the alphabet. Surely we can pick a different variable. So it should say A squared plus 14A equals negative 48. I would love to factor this, but I can't yet. What do I need to do first? To get the point. And we got to add 48 to both sides. A squared plus 14A plus 48 equals 0. Why am I excited about this problem? Besides the fact that I'm a math teacher, what makes this easy? Well, equals 0, it doesn't make life nice, but what I know this problem is an easy factor because that leading coefficient is a 1. It's got a nice leading coefficient of a 1. It's going to end up being nice and pretty. So I need two things that add to 14. I need two things that multiply to 48. Yes, the word so get your point. So 8 plus 6 is 14. 8 times 6 is 48. So A plus 8, A plus 6. Okay, but Nick pointed out that equals 0. So we actually have to keep going. We want to know two answers. So I do A plus 8 equal to 0. And I do A plus 6 equal to 0. And what are my two answers? I know it was you. Was the other voice Justice? Okay, perfect. Then you have the point. Why do quadratic problems have two answers, or up to two answers? How did I know when I looked at this problem how many answer choices I would have? It's okay, you haven't done math in a couple weeks. I'm not mad. We had that exponent to 2. The highest exponent to 2. The highest exponent was a 4. There could be up to 4 answers. We're eventually going to come to fun things like that. Not today. I'm going to skip number 2 for now. Why am I skipping number 2? Because the leading coefficient is 2. You can have a point. I'm going to go to number 3. You would say, well, the leading coefficient is 7. Why would you come to that one next? But other things happen. What can I do on number 3? Which is? Yes, so it was you, right, Jack? 4 and 5, you get a point. So if you factor out an x, you would be left with 7x minus 4 equal to 0, because there was a GCF, Ellie was correct. And I have two answers. One of my answers is x equals 0. What is my other answer? One of my answers is x equals 0. What is my other answer? Yes. So we're figuring another point. So I've set 7x minus 4 equal to 0. Add 4 to both sides, divide by 7, so x ends up equaling 4 sevenths. Thank you. Okay, but now we've got to be brave and go back to number 2. Number Number 2 is not an easy factor because that leading coefficient of a 2. I like to do guess and check. What is the name of a different method we've learned? Starts with an S. You do it on the playground. Yeah, it was slide, divide, bottoms up. You know the point. It was, I like guess and check, so I'm going to do guess and check, but if you want to look back over your notes for slide, divide, bottoms up, you can figure it out that way. I know it's 2a and a, because 2a times a is 2a squared. And I'm positive about the orange. What I'm not positive about is what's put here and here. I have some options. What are my options? I could do 5 and 2, or I could do 1 and 10. And then I have options with signs, because I could do positive 5, negative 2, negative 5, positive 2. I could put the 2 here, the 5 there, and then Jackson's right. I've got this whole same argument with 1 and 10s. So literally, I'm just going to guess. I think maybe the 2 here, just because I'm thinking 2 times 2 will give me 4. And maybe the 5 here. I'm guessing. If I'm wrong, I'm going to go back and change it. Maybe my next guess, I'll guess a negative 5 and a positive 2. Maybe I'll make them swap places. I don't know. I've got to check this out and see if it works. How do I check myself? What method do I use? It is distributing, but that kind of distributing has a fancy name. FOIL. Okay, we're going to give 2 the point though. Okay, so 2a squared minus 4a plus 5a minus 10 equals 0. Did I guess correctly? Yes, because when I combine those middle 2 terms, negative 4 and positive 5 gives me a positive a. And then suddenly I've got 2a squared plus a minus 10 equals 0. Hey, that's what I had to begin with anyway. But silly Miss Compton, she used up all her space to check her guess, and she still hasn't figured out the 2 answers. So I still have to figure out the 2 answers. I set each term equal to 0. And I end up with 2 answers. What are these 2 answers? A point for each then.
A equals 2.
There's 1 point. And a equals, and there's the other point. Woo! You know, we spent a lot of time last semester on you could graph these. See where they cross the x-axis. I bet they cross at negative 5 halves and 2. You wouldn't have to factor leading with, but I digress. Notice factoring is back in here to stay because 4 through 7 is more factoring stuff, so yay, factoring. Okay, you got another handout on your way in the classroom. We're going to look at it in just a second, but first let's look at your packet. Did I give everyone a packet or did I get distracted? Okay, let's look at the new packet. Now, I'm going to remind you what we were doing last 9 weeks before we jump into what we're doing this 9 weeks. Because Lord knows everyone needs a gentle reminder every now and then. So, we've started chapter 5. We're done with chapters 1 through 4. Chapter 3 was major C's, chapter 4 was lovely quadratics, and then chapter 5 we had just started. We actually took a test on 5.1 before you left. In 5.1 we talked about how to add, how to subtract, and how to multiply with polynomials. So for instance, you do not have to write this down, I'm just talking to you to remind you what we've been doing lately. Okay, so we've had polynomials like this. There's a plus sign in the middle, so I'm supposed to add my like terms. So we said 3 plus 2 is 5, so it's 5a squared. 4 minus 2 is 2, so it's plus 2. Most people were great at that. Most people were also great at subtracting. Let's say we had the exact same 2 polynomials. But instead of an addition sign, there was a subtraction sign. So it'd say 3 minus 2, that's only a squared. 4 minus a negative 2 would be 4 plus 2, which is 6. And most of us were great at addition or subtraction. And most of us were still great with multiplication because we would just FOIL. First, outer, inner, last. I know you know how to do the multiplication one. We only had one tiny issue on the last test. And it's that Angel got in a hurry, or whoever, everybody, literally everybody. People got in a hurry, and they tried to make every problem into a FOIL problem instead of looking to make sure, is there a plus or a minus sign in between? Obey the signs. If there's a plus sign, you're not supposed to FOIL. If there's a minus sign, you're not supposed to FOIL. Okay, so that's what we just tested on before we went, before we got ready for semester exams and all that. And then you're like, Miss Compton. So we add, we can subtract, we can multiply with polynomials. Why can't we divide? And we can. That's what we're going to talk about today. Division is always tricky in life. So that's why it requires its own little separate section. Division. Okay, so let's look at the first problem on your new handout. I actually want to change one tiny thing before we get going. I'm going to add a y next to 18x squared. Okay, so we need to divide polynomials. Now, sometimes life works out really nicely like it does on number 1 and number 2. Sometimes we can use a GCF and end up not even having to divide at all, but everyone ends up canceling out, life works out beautifully. What is the GCF in our numerator on number 1? And it is 3x 2y. She is correct. Looking back now, she is correct. And she can have a point for that. But I'm not going to pull out a 3x 2y. I'm only going to pull out a 3xy. Why do you think I'm going to ignore Paige and only pull out a 3xy? Because I looked at that denominator and said, hey, that denominator is a 3xy. If I can pull in a 3xy to everybody in the top, and there's already a 3xy in the denominator, I can probably make them cancel out. Well, let's make sure it works first. Okay, so if I pull out a 3xy, what would I have left in the first term? Okay, and then what after that? Okay, and then minus what? Perfect. Does everyone agree with Ellie? We're going to give her a point because she handled it all. Although Jax is ready to take over whenever she gave up. Okay, so if you wanted to check Ellie, you could. No, I'm calling her wrong name, Lord. So, I've taught her 2 years, my goodness. 3 times 2 is 6. X times x to the third is x to the fourth. Y times y squared is y to the third. She's correct with that term. 12, x to the third, y squared, negative 18x, x squared, y. Yes, she's completely correct. Okay, and now life is beautiful because there's a 3xy in the top and in the bottom, right? We factored out of everyone in the top, and it's going to cross out with what's in the bottom. And so our final answer is 2x to the third, y squared, plus 4x squared, y minus 6x. That's it. We didn't actually divide, did we? We just pulled out a GCF and ended up cross-canceling. And that was lovely. We're going to try the same thing on number 2 because it's going to work on number 2 as well. But this is not always going to work. So that's what we're going to talk about today is how to use long division because this problem worked out perfectly. Most don't. Okay, on number 2, it doesn't even look like a division problem. How do I know it is a division problem? Thank you, dear. And what are you supposed to do with that negative exponent? And you can have 2 points. See that negative 1? That's why he's sending that entire term, 4c squared b squared, to the denominator because of that negative 1. And that is why we went over rules of exponents right before we got ready for that semester exam. Okay, and if I asked Paige to tell me the GCF for the top, what would she tell me? Now, Paige is thinking like me, and that is what I'm going to pull out because I want the top and the bottom to cancel out. But what is the actual GCF for the numerator? No, she's right with the c squared d squared. But there's a bigger number than 4 we could pull out. I'm not going to, but we could. Could pull out an 8, but we're not going to. I agree with Paige. I'm trying to make the top and the bottom cancel out. I noticed this pattern. I'm rolling with it. Okay, so what would I have left? Not Ellie. If I really did factor out a 4c squared d squared, what would I have left in the numerator? Okay. Oh, I did auburn colors. So. Oh, I love you, Paige. My husband would love that too. Okay, and then I'm excited. Why am I excited again? Yep, and so my final answer is what was in blue. So 4c squared d to the third minus 6. That's it. We're done. Wow. Hey, I know GCF, so you're telling me if I can factor out something in the top, so that way I can cross the top out with the bottom, then I don't actually have to divide? Yes. Does that happen a lot in life? No. But it sure is nice when it does. It's always smart to check for a GCF. The same way if you don't check for GCF, you end up like killing yourself trying to factor. If you don't check for a GCF with division, you might kill yourself trying to do long division, and life could have been a lot easier. So always check for the GCF first. Okay, on your way in, you picked up a useful handout. It said something about long division. We're going to look at it now, and we're actually going to fix something on it. It's got a little typo. Take that 6 and move it over. Okay, so I'm going to work out the one problem from this handout, but otherwise this handout is really just for you. If you don't understand the words I say today, or if you just need an example to look back over quickly, they explain themselves really well, especially in the very bottom example. They explain like the little thought bubbles tells you why they thought what they thought. Okay, so you did discuss long division when you were in school, like elementary school. So you had to do this problem before in life. If you wanted to see how many times 7 went into the number 1, 2, 3, 4, you would make a house, and you're going to help me walk through this. And eventually we got lazy and we stopped actually working it out, and we started just asking your calculator and getting an answer that way. Okay, but we're not being lazy today. So 7 doesn't go into 1. How many times does 7 go into 12? 1 time. So 7 times 1 is 7. Now what do I do? Okay, so 12 minus 7 is 5. 7 doesn't go into 5. What do I do now? Oh, okay. So if I bring down the 3, I have 53. How many times does 7 go into 53? Okay, so P.S. the answer's on your handout. So 7 times 7 is 49. So I subtract 49. I end up getting 4. I bring down the other 4. And 7 times what is 44? Well, 7 times 6 is 42. So I subtract, and I'm left with a 2, and then I'm out of numbers to bring down. So what would I do then? So I've got a remainder. That's a word that we hadn't heard in a while. How did you know to put that 2 over the 7? So it's 176 2/7. That's just what you're supposed to do. That's the same thing today. So if we end up getting a remainder down here, we're going to put it over the thing on the outside. We're literally going to have a very similar process, but you did just numbers, and we deal with variables, so we're going to make it with polynomials. So we're going to have x's and y's and some other things involved, but it's still this same process of trying to figure out what our remainder is and how we can get to a more simplified answer. Okay, so again, your handout has 2 useful problems. I'm going to try to work 3 and 4 today. And then you seriously have no homework because I just can't first day back. That's just terrible. But know that eventually you're going to have problems you have to do on your own, so you need to understand or ask questions if you don't. And also, as equally important, eventually, of course, as always in math class, there is a test, and there will be long division problems. Okay, so we are still going to make a house. We're going to ask how many times does x minus 5 go into x squared plus 3x minus 40. So just like when you were doing long division with numbers, you made a house, we're still making a house. We're still asking ourselves, like, how many times does x go into x squared, or what times what gets me x squared? And you're like, oh, x. Isn't x times x, x squared? But what's different with long division with polynomials is that minus 5. We used to just have the number, or just one thing. So now we've done x times x and gotten x squared. We also have to do negative 5 times x and get negative 5x. Okay. That's where I normally lose people. Are there any questions about the pink? So yes, x times x is x squared, but also you still have to deal with the negative 5. So negative 5 times x, negative 5x. Are there any questions about the pink? Yes, dear?
So first we deal with the x and then just do the 5.
Yes, so whatever you multiply the x by, you've got to multiply the negative 5 by. They go together. They're a team.
So would it be like?
Would it be like, so this is why it's different than what you were doing, the other long division with numbers, because it's extra thought you got to put into it. But from here on out, it's the same sort of process in that, didn't we subtract? And then don't we bring down stuff? We're still going to subtract. We're still going to bring down. It's just instead of only having one thing to keep up with, we end up having 2 every time. Or, you know, if it was a really long thing over here, it could be 3. Okay, so we subtract, and the reason we subtract is because if we added x squared, we would get 2x squared. Does that make our life any easier? No. We're trying to get lower, so it makes sense we're subtracting. X squared minus x squared, those go away. 3 minus negative 5. How many x do I actually end up with? Yes, you can have a point. So, and you can see, oh crap, this looked okay, and now I've really got to pay attention to signs. Because I thought it was going to be negative 2. 3 minus 5 is negative 2. But really it's 3 minus a negative 5. So it ends up being 3 plus 5, which is 8. So a lot of people, if they're going to make a mistake, they make a sign error right there. Okay, so are there any questions about the green? Well, now we're going to go through the same process of x times what will give me 8x? Well, we've got to multiply by 8. That makes sense. X times 8 is 8x. But I did 8 in the x. I still got to do negative 5 in the 8. So I got 8x, but I also have a minus 40. Oh no. My orange minus 40 does not have a friend. What do I need to go and do? I need to go bring down that other thing. Any questions about how we got the orange? And then just like on the other line, we're going to subtract. We really want those 8x's to cancel out. So 8x minus 8x, the 8x's cancel out. Negative 40 minus a negative 40. They end up canceling out. We end up getting what number down here at the bottom? Yes. So do we have a remainder? Does that always work out in life that way? No, absolutely not. Well, why did this one work out that way? Probably because they wanted us to be able to check ourselves. So if we checked, so we thought when we divided x minus 5 into x squared plus 3x minus 40, we thought we would get x plus 8. So we could check it by multiplying. Is x minus 5 times x plus 8. If we FOIL that out, do we really get x squared plus 3x minus 40? Let's see, x squared plus 8x minus 5x minus 40. I combine my like terms. Yep, I really do end up getting x squared plus 3x minus 40. So this problem works out that way That way you and I could check it with foiling. So let's, don't overcomplicate your life. I realize it's the third day and you've not done math for 2 weeks. But it makes sense that we were dividing. And so to check it, we multiply. When we multiply the two, do we actually end up with what we had tried to divide by? Yeah, it does. Or, we tried, that was our dividend and divisor. I get all this. Okay, are there any major questions? Okay, we're going to do number 4, and then we're going to call it a day. Okay, number 4. I'm still going to make a house. I'm going to put 2x plus 1 on the outside. I'm going to make a house. And before you go too crazy, there is one teeny tiny thing we need to fix before we put this polynomial underneath the house. Tell me something curious about the thing I've highlighted. Are they like terms? They have different exponents. Something is missing. What is missing? Look at the exponents. Which one's missing? X to the what? 3. I see a 4. I see a 2. I see 4, 2, 1, right? Where's the 3? There isn't a 3. Did it bother us? No. Is it going to be important now? Sadly, yes. So if I don't have one, so I'm still going to put 8x to the 4th. I don't have any x to the 3rd, so I'm going to put 0x to the 3rd. That is a great question. Okay, so let's look back at our thing I highlighted. We acknowledged it had a 4, a 2, and a 1, and then they had skipped 3. And, at first I thought, I'm going to skip 3 too. You can't, because when we multiply, in fact, let's do the first step, and then you'll see why. You'll see why. So if there's ever a missing exponent, put zeros in for missing terms. Now, why they had to do one straight out the gate with somebody missing, I don't know. But anytime someone's missing, the way the x to the 3rd was missing, you need to put in a 0 as like a placeholder. Otherwise, you know how our lines were so pretty in, let me zoom out. You know how our lines are so pretty and lining up just so? Stuff won't line up just so if we don't put in this 0 placeholder. Okay. So I want to know how to get 2x to become 8x to the 4th. So 2 times what will give me 8x? 2x times what will give me 8x to the 4th? 4x to the what power? Yes, it has to be 4x to the 3rd. Because 2x times 4x to the 3rd gives you 8x to the 4th. Everyone good with the pink so far? Okay, but I multiplied 2x times that. I still have to multiply 1 times that. So 1 times 4x to the 3rd, I get 4x to the 3rd. And now you're like, and this is why I put in the 0. This right here. Because otherwise, I would have had that pink 4x to the 3rd, and he wouldn't have matched anybody. So if we hadn't put in that 0, who would 4x to the 3rd combine with? Okay, so we've got to subtract. So 8x to the 4th minus 8x to the 4th, we get 0. 0 minus 4x to the 3rd, we get negative 4x to the 3rd. Are there any questions about the orange? Okay, well, I'm getting smart. Since we've got 2 guys out here, I need 2 guys down here every time. So I know I should probably go ahead and bring down that negative 4x squared. Okay, I'm trying to figure out how to get 2x into negative 4x to the 3rd. So what times what? 2x times what can give it to negative 4x to the 3rd? Okay, well, that makes sense. 2 times negative 2 is negative 4. X times x squared, you add the exponent so you get x to the 3rd. But since I did 2x times that, I have to do 1 times that. So 1 times negative 2x squared gives me negative 2x squared. Are there any questions about the blue? Okay, well, we need to subtract negative 4x to the third minus a negative 4x to the third. Those cancel out, so I have 0x to the third. That's what I wanted. I wanted the thirds to go away. But now I have negative 4x squared minus negative 2x squared. So what should I actually end up with? Yes, Paige? Yes. So it was negative 4 minus a negative 2. So it was negative 4 plus 2, which is negative 2. Yes. And you can see how most people will make a sign error. As long as Anne-Marie perseveres and continues to go and try and work the problem, I'm going to forgive her for the teeny tiny sign error and take off very minimal points. But if she then quits after she recognizes she made the sign error, it's kind of hard to have pity points then, isn't it? Okay, so I brought this down. I'm getting closer. There's only one more thing I could possibly bring down, so the end must be near. Okay, so I need to get 2x to somehow become negative 2x squared. So I need to multiply by what? Yes. If I multiply by negative x, 2x times negative x is negative 2x squared. 1 times negative x is negative x. Are there any questions about the lime green? Well, just like with the other lines, we need to subtract negative 2x squared minus a negative 2. Those x squareds end up canceling out. Yay, that's what we wanted. But then I have x minus a negative x. So I end up with x plus x, which is 2x. Because I had x minus negative x. So I actually have x plus x, which is just 2x. Okay, and then you're like, well, Miss Compton, bring down that 4. There's only one more step possible because there's no one else to bring down. We brought down the last thing. There's no one else to bring down. How do I go from 2x to 2x? What do I multiply by? I'll put a plus 1 up at my top. I need to zoom out. This is long. So 2x times 1 is 2x. 1 times 1 is 1. But I've got to subtract that second line. I have 2x minus 2x, I get 0. I've got 4 minus 1, I end up with 3. Okay, I have a remainder. So I'm going to write that as a fraction. So go back up to the top. I'm going to put plus 3 and then divided by the whole thing we were dividing into. So, or we were dividing by. We were dividing by 2x plus 1. So it took forever, but our answer is 4x to the third minus 2x squared minus x plus 1, and then plus that remainder, 3 over 2x plus 1. Okay, if you followed that, you're going to be great. If not, I swear we're doing it again tomorrow. You got to get on board. I know, we just hit the ground running. My bad. I wish I could prevent it, but I cannot. If you want to pack up, that's fine.